Okay, good morning. So I just want to make this video as a quick introduction to aldehydes and ketones. Hopefully you've had a chance to look through the booklet that I've sent you. So we're going to start by just a bit of a reminder about what they contain. So we covered this in our AS topics, but they all contain, or both aldehydes and ketones contain this carbonyl group. Okay, so the general structure of an aldehyde has the carbonyl group at the end of the chain. And the example is propanol, butanol, pentanol. They all have them at the end of the chain, and they all end, when you're naming them, they all end in al. Okay, the ketone is slightly different because the carbonyl group is in the middle of the chain. So you've got these two other carbons attached to it. Can be varying length, that's why they're not both the same. And the example here is propanone. So the carbonyl group's in the middle and it ends in one, propanone. And then butanone, but we can also, for longer ones, remember, for the ketones we can have position isomers. So for if you have more than 4 carbons, you're going to have position isomers. So why don't you pause the video now and see if you can draw the structure of pentan 2-one and pentan 3-one and see how they're different. Okay, so just pause it now and try that. Okay, so if we remember how they were made, so think back to AS. When we were doing the alcohols topic, we looked at how aldehydes and ketones could be made from alcohols. So they were made by the oxidation of primary alcohols made in aldehyde. So remember, we used acidified potassium dichromate as our oxidizing agent. So in this equation here, remember that the O in square brackets just represents the oxidizing agent. And in this case, it was acidified potassium dichromate. And if you remember doing this, the colour change was from orange to green. So that's when you knew the oxidation had happened. It went from orange to green. Okay. This is the apparatus that you need. So you have your primary alcohol in the round bottom flask with your oxidizing agent. And it's heated at the minute as orange. And once it's oxidized, then it'll turn to green and your aldehyde will be given off. Now it is important that you have the right setup for the apparatus, that it is distillation, not reflux. Because remember, if you reflux it, then you'll get further oxidation and you'll get a carboxylic acid formed. And I think that was one of the experiments that we did in class, trying to get the aldehyde instead of the carboxylic acid by distillation, not reflux. Okay, remember then to get a ketone, it's oxidation of the secondary alcohol. And again, we can use acidified potassium dichromate, and the colour changes from orange to green for this one as well. So in this case, we have propanol oxidized to go to propanone. Okay, and the other product is water. So testing for aldehydes and ketones. Hopefully you've had a chance to look at the videos that I asked you to look at yesterday on YouTube. There are 2 ways. So Holland's reagent. If that aldehyde is present, you get a silver mirror. And maybe in my classroom, you have seen this conical vase sitting on my shelf where it has a silver mirror on it that was formed. And we have it sitting on, there's test tubes as well, and boiling tubes that have it, but it's really cool looking. We'll do this experiment when we're back in class. And with the failing solution, if the aldehyde is present, you get a brick red precipitate. I've got a picture of it just on the computer if you can see. So the failing solution is a blue solution, and if the aldehyde is present, then you get a brick red precipitate. Again, we can do this experiment when we're back in class. Remember, this only is a positive test for aldehydes. If a ketone is present, then you don't get any of these. There's no change happens. Okay, so reactions then of aldehydes and ketones. This is on page 7 of your booklet. If you need to, you can pause and rewind any of this video and watch it again if you want to go through it again in more detail. So remember, how we formed aldehydes and ketones, it was by the oxidation of alcohols. So if we reduce an aldehyde or ketone, we'll go back to the alcohol that we started from. But we need a very strong or very powerful reducing agent to do this. And the reducing agent that we use is lethal. I'm just going to get a bit of cell tape ready so my page doesn't move. Okay, so remember that ketones are reduced to secondary alcohols, aldehydes are reduced to primary alcohols. But the lethal is important because it produces this hydride ion, and the hydride ion is different because it has a lone pair of electrons on it. And the carbonyl group that we have, remember, in both aldehydes and ketones, is susceptible to attack by a nucleophile. And this hydride ion is a nucleophile that attacks the carbonyl group. And if you remember from your definitions for AS, A nucleophile is an ion or molecule with a lone pair of electrons that attacks regions of low electron density, which is present in the carbonyl group. Okay, so if we look at page 7 now, where it talks about how these reactions for the reduction of aldehydes and ketones. So this is the one at the top, page 7, where we start with an aldehyde, so this is propanol. And then in your, remember our oxygen in square brackets represented an oxidizing agent. So in this case, the hydrogen in square brackets represents the reducing agent. And to balance it, we need 2 hydrogens. I'll show you why in a wee second. And then we get our primary alcohol formed. Now, that is all you need to know. You only need to know the reaction or the equation for these. You don't need to know the mechanism. But I'm going to try and explain this mechanism to you to help understand why it's 2 hydrogens that we need. Okay, so remember we talked about how the lithyl is such a good reducing agent because it produces this hydride ion, which is a negative charge hydrogen that has a lone pair of electrons. And remember it was defined as nucleophile because it has a lone pair of electrons that attacks regions of low electron density. So if we look at our carbonyl group, we've got our double bond between our carbon and our oxygen. We know from last year that oxygen is more electronegative than carbon, so it's going to attract the electrons towards it. It's going to be delta negative, and the carbon's going to be delta positive. So that is the carbon delta positive is the one that the lone pair of electrons from the hydrogen is going to attack first, isn't it? And that's going to cause this double bond to break. And we'll get an intermediate then formed where we have our oxygen with the double bond. Got the hydrogen from the hydride ion has joined onto this carbon, and it still has its own hydrogen, and then we still have our hydrogens on these carbons as well. Now, a lot of this is done, there's water present. We're going to have another hydrogen ion present. This is our second hydrogen from our equation. But this hydrogen is formed whenever this lone pair of electrons attacks a water molecule and then pulls one of those hydrogens away from it. But for this mechanism, I'm only going to draw it just as a hydrogen ion. So the lone pair of electrons are going to go attack that hydrogen ion. And then our product, I'm just going to do a wee arrow down here. You'll see then that we will get our primary alcohol formed. We've now got propan-1-ol. Okay, so again, you only need to know, the only thing you need to know in this page is your equation here. You don't need to know the mechanism, but I wanted to show you where these 2 hydrogens come from. Okay, so at the bottom of page 7, then we have got for our ketone, so it's the same thing. I'm going to just stick cell tape there, stop it moving. So we have our lithyl, and it's going to turn, so we're going to have our CH3CO CH3 plus our 2 hydrogens is going to go to CH3. So we're going to have a CHOH because we're going to put our alcohol group there, CH3. Okay, so the lithyl, I'm not going to do the mechanism again for you. You can have a go at it yourself if you want to. Pause the video and try the same mechanism that we did at for the previous page. You can have a go at it if you want. I'm just going to draw what the finished product is. So we've got our secondary alcohol, which is propan-2-ol. Okay, so propan-2-ol. Okay, and again, remember this is the hydrogen in square brackets in the equation just represents our reducing agent, and the reducing agent is the hydride ion from this lithyl. The lithyl is a reducing agent, and the lithyl acts as a reducing agent because it produces the nucleophile, the hydride ion. Okay, hopefully that makes sense. You can rewind it and watch it again if you want to. You can send me a question on Teams or on Google Classroom and I'll answer it as best I can. And I would like you to complete all the questions up to page 8 and submit all the work in Google Classroom, please. Thanks.